All right, so today we are going to unravel a pretty wild story. It's a story that connects the super detailed world of video games to the, multi-trillion-dollar AI revolution. And believe it or not, it all comes down to one single mathematical operation that pretty much changed everything.
So let's dive into this. We're going to start with a puzzle, a real head-scratcher that has completely reshaped the entire tech world, and in the process, created one of the most valuable companies on the face of the earth.
And here's that puzzle. How on earth did NVIDIA, a company that for decades was famous for one thing, making your video games look absolutely stunning, how did they suddenly become the undisputed king of artificial intelligence? I mean, what is the connection there?
And look, we are not talking about a small change here. NVIDIA's value has just exploded, soaring into the trillions, all riding this massive AI wave. So to solve this mystery, we really have to get back to basics and understand what AI is actually doing under the hood.
You see, when you strip away all the hype and all the complexity, AI really boils down to just one main goal: prediction. That's it. It's about teaching a machine to sift through a mountain of data and find that hidden recipe, the secret pattern that's buried inside.
Let me put it this way. Imagine you want to predict a person's risk of heart disease, right? You've got a ton of inputs: their age, their weight, their blood pressure, if they have diabetes. The whole point of the AI is to find the perfect recipe that combines all those inputs to accurately guess the final outcome, high risk or low risk.
Okay, so this table right here, this is what that actually looks like. The AI gets fed millions, and I mean millions, of rows just like this. Now, in math terms, that recipe we're talking about is called a function, or f. It takes all those inputs, which we call x, to predict the final outcome, y. The entire game is finding that perfect function. So how exactly does it learn the recipe?
So how does the AI do it? How does it find that hidden pattern? Well, we can kind of visualize its thinking process as this big, complex structure called a neural network. You can basically think of it as the AI's brain.
It really works like a giant assembly line. All that patient data goes in one end and then passes through all these layers of artificial neurons. At every single connection point, the data gets multiplied by something called a weight, which is really just a number that dials its importance up or down. Think of it like you're adjusting millions of tiny little knobs on a giant soundboard. Training the AI is just the long process of tweaking all those knobs until the prediction that finally pops out the other end is accurate.
And this right here, this is it. This brings us to the absolute core of our entire mystery. What is the one single mathematical operation that is happening billions and billions and billions of times inside this huge network of knobs and neurons?
That's it. Matrix multiplication. The whole mind-bendingly complex process of an AI thinking literally just boils down to taking huge grids of numbers, our data and all those weights, and multiplying them together, over and over and over again.
And the scale here is it's honestly hard to wrap your head around. Even for one tiny little part of this massive network, the number of multiplication steps is absolutely staggering.
Let's just try to put a number on it. A really small batch of data, say 100 patients passing through just one small layer of 200 neurons, that requires 140,000 multiplication operations. Now imagine a real network with thousands of layers crunching millions of data points and repeating this process hundreds of times. The numbers just get, well, they get ridiculous.
So, the big question is, how in the world do you actually do all that math? Well, a standard computer processor, a CPU, is like a single master chef. It's incredibly fast for sure, but it does one thing at a time, one after the other. It's sequential. A graphics processor, a GPU, is totally different. It's like an army of 1,000 assistant chefs all chopping vegetables at the exact same time. It does thousands of simple, identical things all at once, in parallel.
So why on earth were GPUs built to work like an army of chefs? Well, this is where the mystery finally gets solved, and it's a story of pure, beautiful accident, or as our source material puts it, providence.
Because it turns out that rendering realistic 3D graphics in a video game requires the exact same type of math. Yep, to move a character across the screen or to create an explosion, the computer has to multiply a big grid of screen pixels by a big grid of character pixels, and it's got to do it thousands of times every single second.
This timeline just lays the whole story out perfectly. For decades, NVIDIA was busy perfecting hardware for one reason and one reason only: to make video games look incredible. And in doing so, they were, completely by accident, building the perfect engine for the AI revolution that was just around the corner.
So when AI researchers desperately needed a way to perform trillions of these matrix multiplications, the answer was already sitting on the shelf, built for gamers.
Okay, so after going through all that, what's the big lesson here? What should we really take away from this incredible story about gaming and AI?
Well, it means that this entire technological revolution, for all of its amazing complexity, is actually built on a surprisingly simple mathematical foundation. It shows us that our progress in AI is fundamentally tied to our ability to just build better, faster calculators. And maybe most importantly, it's a great reminder that the next trillion-dollar innovation might be hiding in plain sight, being developed right now for a completely different purpose.
And that kind of leaves us with one last really fascinating question to think about. What technology are we all using today, maybe just for fun or for convenience, that might hold the secret key to unlocking the next massive scientific revolution? Thanks for watching.